ABC Public School, there are 576 students lined up in such a manner that the number of rows is equal to the number of students in a row. How many students are standing in a row? If you assume the number of rows to be x, the number of students in a row is also equal to x. Therefore, x multiplied by x is equal to 576. Or x squared is equal to 576. Now, you need to find the number whose square is 576. For this, you will use the concept of square roots. Calculating the square root of a number is the inverse operation of squaring a number. 2 square is equal to 4, and minus 2 square is also equal to 4. Therefore, you can say that the square roots of 4 are 2 and minus 2. Similarly, the square roots of 49 are 7 and minus 7. Thus, you can say that every number has 2 square roots, one positive and one negative. In this topic, only positive square roots will be covered. The positive square root of a number is denoted by this symbol. Let's look at the square roots of some more numbers. 5 square is equal to 25. Therefore, the square root of 25 is 5. Similarly, the square root of 144 is 12, and that of 225 is 15. The sum of the first n odd natural numbers is equal to n square. You will use this rule to find the square root of a number. Consider the number 49. Now, starting from 1, subtract odd numbers from 49 until you get 0. The total number of subtractions you performed is 7. Therefore, the square root of 49 is 7. This process of finding square roots is called the repeated subtraction method. Remember that if repeated subtractions do not give a 0 at the end, it means the given number is not a perfect square. Let's take another example of finding the square root of a number by using the repeated subtraction method. Suppose you need to find the square root of 25. Applying the repeated subtraction method, you get 25 minus 1 is equal to 24, 24 minus 3 is equal to 21, and so on. Count the number of subtractions you performed. It is 5. Therefore, the square root of 25 is 5. Another method of finding the square root of a number is called prime factorization. This method is generally used for large numbers. This table shows the prime factorization of some numbers and their respective square numbers. For example, the factors of 10 are 2 and 5, while the factors of its square number 100 are 2, 2, 5, and 5. Note that each factor appears twice in the case of 100. Similarly, the factors of 12, 2, 2, and 3 appear twice each for 144, which is the square of 12. Therefore, we can conclude that each prime factor of a number appears twice in the prime factorization of the square number of that number. Let's use the prime factorization method to find the square root of 7056. The prime factorization of 7056 is shown below. Therefore, you write 7056 as a product of these factors. Now, let's make pairs of the factors by underlining them. You have 2 pairs of 2 and 1 pair each of 3 and 7. To get the square root, pick one number from each pair. Therefore, the square root of 7056 is 2 into 2 into 3 into 7, which is equal to 84. You may also use this method to check whether or not a number is a perfect square. For example, is 180 a perfect square? If not, then by which smallest number should 180 be multiplied or divided to get a square number? The prime factorization of 180 is shown. Therefore, you can write 180 as a product of the factors obtained. Since 5 has no pair, 180 is not a perfect square. To make 180 a perfect square, you need to multiply both sides by 5. Thus, 5 is the smallest number that 180 can be multiplied by to make it a perfect square. So, the perfect square number is 180 multiplied by 5, which is 900. To make 180 a perfect square, you can also divide both sides by 5. Thus, 5 is the smallest number that can divide 180 to make it a perfect square. So the perfect square obtained after dividing 180 by 5 is 36. Do you know we can estimate the number of digits in the square root of a number? Observe